Alright, so Assalamualaikum and good evening. My name is Muhammad Malakim bin Muhammad Istaini. I am the presenter for Group 7. So after weeks of research, we are finally able to approach and to solve the problem. So without further ado, I will discuss on what methods do we use to approach the problem and solve it. Alright, so here the questions given to us is as follows. Given the following functions, find its Fourier transform mathematically. Show your answer clearly. Okay, so here we have ft equals to 1 when 1 is less or equal to modulus t and modulus t is less or equal to 2, and elsewhere the function is defined as 0. Okay, here's the solution. First, you must define t as its modulus or an absolute value. It is defined as negative 2 less or equal to t, and t is less or equal to 2, t is more or equal to 1, and t less or equal to negative 1. So therefore, with this in mind, we can deduce that negative 2 is less or equal than t and less or equal to 2, t more or equal to 1, and t less or equal to negative 1. This is the graph that we sketch from the function. As you can see here, at intervals 1 to 2 and negative 2 to negative 1 respectively, the function is deduced as 1, whereas elsewhere the function is at 0. Okay, so moving on to the steps to find its Fourier transform. So first, here is the general formula of the Fourier transform, and as we discussed earlier, we find based on the graph we can see its respective intervals. Okay, so we deduce that our Fourier transform is deduced as the integral of e to the power of negative j omega t from negative 1 to 2, from negative 1 to negative 2, and the integral of e to the power of negative j omega t from 2 to 1. Okay, so once we have find this, we start integrating. As you can see here, we start to integrate. Here are the steps shown here. Alright, as you proceed, now if you notice, we sort it by the powers. For example, here the powers here respectively is 2j omega and negative t 2j omega respectively, and from here the powers are j omega and negative j omega. We do this because on the next step it will be much easier to make it easier to proceed to the next step. Right, so now I will discuss. Okay, for this solution we have one key point so that we can solve it, which is e to the power of j omega minus e to the power of negative j omega over 2j omega equals to the trigonometric sine omega over omega, which equals to sec omega. So with this in mind, now we must find out how to convert these forms into this form. So to solve that, we use equivalence. For here we use 4 over 4 and 2 over 2 here respectively. Alright, why here we use 4 and why here do we use 2? Because the answer is at the exponentials. So if we compare to the original equation above here, For example, here is j omega, negative j omega, and j omega, 2j omega, negative 2j omega. So we must, but here is j omega, so therefore we must equivalent it so that all here, all the powers include, and the denominator must be equal to 2j omega, and same goes to here, which is basically the same thing. Alright, so once we rearrange it, we will get into this form, as you can see here. So once we have converted into this form, alright, as you can see here, we can finally deduce that 4 sine 2 omega over 2 omega minus 2 sine omega over omega. Alright, because if you see the function previously and compare it, we can convert it into its trigonometric form right here. Okay, so now with that in mind, we can deduce it as 4 sec 2 omega minus 2 sec omega. Alright, this is our final answer. So our Fourier transform is equal to 4 sec 2 omega minus 2 sec omega, where sec omega is defined by sec sine omega over omega when omega is not equal to 0. This is important because when sine omega over omega approach is at 0, the function is undefined, and 1 whereby omega equals to 0. So this concludes the mathematical part of the solution, and now I shall move on to how to solve, how do we plot the graph in MATLAB. Alright, so I already opened MATLAB. So for this code, we've done some research for quite some time. However, the solution was actually in MATLAB's website. So yeah, okay. Now I will break down our code so that we can understand how it works. So for the first line, we can see W equals to negative 8 colon 0.1 colon 8. Negative 8 and 8 respectively represents its range or frequency for the x-axis, which is negative 8, x-axis 8. Okay, 0.1 represents the divisions, the increments or decrements, which we will show at the y-axis. Okay, so for the second line, we define the function required to plot, which is p equals to 4 sec 2 omega minus 2 sec omega. Okay, for the third line, we use figure plots W as in here, ABSP title, amplitude spectrum, X label frequency, Y label, modulus F J omega, sorry. Alright, plot W ABSP is to plot the function, and title, it will display the title. X label will display the label at the x-axis, and Y label will display the title at the y-axis. So to form the amplitude spectrum, we have to use ABSP. It is the MATLAB library for defining the amplitude spectrum of the given function. So I will proceed to line 4. Line 4 is similar to line 3, however with a few differences. The first one is that it is to plot the phase spectrum. Okay, as you can see here. So the only differences are the title and here, which is W, angle P. Angle P is the MATLAB library to enable us to plot the phase spectrum. Okay, so when I run it, we are presented with two graphs here. As you can see, on the left you can see the amplitude spectrum, title and all, and the same goes to here, the phase spectrum. So thank you for listening. This therefore concludes our discussion on how do we approach and solve the problems, and also how do we manage to plot the code in MATLAB. So with that, I thank you.